So, if someone loses his left eye, it is quite clear what the defect will be. If he loses his left eye, he will only be able to see from his right eye. Same thing would happen if he loses that. Because the nerve fibers that are coming out of here have not decussated. All the visual information that is in your left eye will be knocked off. You'll essentially still be able to see from your right eye. You'll be able to see aspects of your left visual field up to here, because obviously this part of the visual world, not enough light is actually, no light from here is falling on your right eye, and you'll be able to see your right visual field. So all of your right visual field and a little bit of that. This part will be excluded just because it's too far out. Now, what would happen if the lesion is here? At the chiasm, we have the nasal fibers of the right eye and the nasal fibers of the left eye, correct? These blue ones and these green ones, correct? Now what are they seeing? The nasal fibers of your right eye are blue. They're getting information from here, correct? So this part. The nasal fibers of your left eye are green. They are getting information from here. What is left? You have essentially cut off this part. You have what they call tunnel vision. What if the lesion is behind the decussation? What if the lesion is here? Or for our purposes, here at 2. What do you see then? Your third lesion. We're having our 2 eyes here. But let's see. We're essentially getting all of the blue information off. Alright, so we have this part of the visual field that's getting inputted into this eye that's going off. Right? We have this part of the visual field that's going into this eye over here that's also getting cut off because all of the blue is cut off. Correct? And so all of this is being cut off, but it's hitting here and it's hitting here, right? And the information is hitting 2 retinas. You have, again, there, but this time it's not tunnel vision that you're getting. You are getting right, because it's in the right visual field, right? It's in the left part of your brain. We're having a lesion there, so it's in the left part of your brain. It's your right visual field, so you're not seeing on your right side. And you're not seeing on the right side of either eye's visual field, so you are getting a right homonymous hemianopia. So, now I would like to focus on the names, the nomenclature. We just call this a right, because it's on the right hand side. Homonymous, same. Right, homonymous, because they're on the same side. Hemi, half, and opia, and without opia, sight. So it's a complex way of saying you're not seeing the right visual field. And the information is coming from both eyes, so you're not seeing the right visual field of both eyes. Now what's number 2 called? Tunnel vision. It is also called bitemporal, temporal, on the side of your temporal lobe, hemi, half, anopia, sight. Okay. So we've now learned complete blindness from one eye, left or right. We have bitemporal hemianopia, and we have right, or left for that matter, homonymous hemianopia. And the last thing I want to tell you is, what if this goes V1? Or your cortex, the part V1, V2. What if these fibers never reach your cortex? You get complete blindness. Same as if this and that goes. You will get complete blindness. Now, what is the difference between blindness at this level and blindness at this level? Blindness at this level, that's it. Completely blind. Blindness at this level can give the curious syndrome of blind sight. And it is the same as that video that I showed you in class, where there's that man who's completely blind and is saying that he's blind, but he seemingly, or he can, navigate his way through a maze without bumping into anything. And that is because, as I told you before, some of these fibers go to subcortical structures. They are processed, but do not reach awareness. Good luck and happy studying.